next time it starts, maybe resumes where you left off. It can all be done at this particular place. But code controlling your views, talking to your model, doesn't generally belong here. Because the method that you might tweak on occasion is this first one. So the name of this method, here's a little quiz question. What is the name of this method? Yeah, or yes?
Application did finish launch with options.
Good. And if you're writing this in prose, you would actually include the trailing colon. So this kind of detail you'll start seeing in the documentation. So that's the name of this method, or the selector, which is similar but different. We'll get back to those before long. So what's going on here? So there's not all that much commenting. Apple put a comment here, which is essentially an instruction to you, the developer, put stuff that you want to add to this here. But what are these other lines doing? Well, on the right-hand side, actually, rather than me keep talking, what's this doing in the square brackets here?
Allocates memory for a UI window.
Perfect. Allocates memory for a UI window. So it specifically instantiates that object. Init with frame, this is now like the constructor that languages like PHP and Java have. And what is it doing? Well, it's initializing it with something known as a frame. Think of it as a picture frame. It's some rectangular dimensions. Where are we getting that frame from? Well, UI screen, main screen is what kind of method? What kind of method is main screen apparently? Class or instance? So it's apparently a class method because, again, there's no mention of alloc, and I have no mention of UI screen until this moment in time. So UI screen must be a class, and passing in main screen's message means give me some kind of pointer or reference to the so-called screen. So another representation of the glass. Bounds essentially returns the dimensions of that screen. So what we're saying in this whole line here to the right of the equal sign, allocate a window and tell that window that your bounds are from here to here, or whatever the shape of the device actually is. On the right-hand side, what is this doing? Self.window equals. So it's setting the property called window inside of self, my app delegate object, to that value. But more specifically, the dot notation in the equal sign means what method is getting called, or what message is actually being passed. Jason? Set window. So there is somewhere underneath the hood a method called set window that was probably automatically synthesized, written for us, not manually, so that this setting from right to left would happen. Jason?
So is this essentially, this is like the bound, if you're working on an iPhone, it's the dimensions of the iPhone screen, but if you're, is that what this is?
Exactly. It's the bounds of the iPhone or the iPad screen.
Or if you're mirroring like the TV or whatever.
Yes, that's another notion of a window. You can have another, or rather another notion of a screen can be an external via Wi-Fi or physical cable connection. Exactly. So for the most part, this is boilerplate. You rarely change this until you start doing fancy things like projecting videos on the screen to some other screen, doing mirroring, or the like. Yeah?
Since UI window is being allowed, it has to be an instance method?
Good question. Since UI window is being allocked, it has to be an instance method? Not quite. Alloc itself is a class method because it's being passed to a class before anything's been instantiated. But init with frame is what type of method? Instance or class? Instance, because it is being passed, albeit in nested form, to what is now an existing object that was returned from that message pass. And just to go back to 3 weeks ago when we first started talking about Objective-C, suppose you're out of memory, and suppose that the alloc call for UI window fails. What gets returned? So nil gets returned. So this seems bad, right? In 50, one of the most common causes for bugs, especially around pset6 time, dictionary, is seg faults, right? When you're dereferencing bogus pointers. But that's not going to happen here. What happens if you nonetheless call init with frame sort of blindly on what apparently could be nil? What happens? It ignores the message. So this is a huge value add of this notion of nil as opposed to null, in that if you pass messages to nil, things won't crash. They will simply be silently ignored. And this allows us to eliminate a whole lot of error checking, for better or for worse, and this nesting of messages so that we can just pass and pass and pass irrespective of whether we get back nil. We can check for nil, in fact, at the very end if we really want to, if self.window itself is nil. All right, so moving on, view controller. So this is essentially the same story, but the instance method we're now calling to initialize what's apparently called a view controller is init with nib name. What's a nib? Yeah. So it's a file containing a user interface. It's the WYSIWYG stuff that we saw 2 weeks ago. Underneath the hood, it's implemented with a file extension called XIB. The useless history there is that it used to be Next Step Interface Builder, NIB. When the tool became Xcode, it became XIB, but you pronounce XIB nib. So for historical reasons. All right, so what is going on here? This is now assigning a pointer to self.viewController to whatever code it is apparently that I am going to now write in this application, in the thing that's actually called viewController.m and .h. This next line here, root viewController gets self-viewController. So apparently inside of a UI window, there is a property that's called root view controller, and it does what it says. This is a property that should be set to whatever view controller should kickstart the whole application. Who should be now handed control of this application? Make key invisible just means make this the key window, which means start responding to finger touches on the screen. Make it visible is obvious. And then I return yes, signifying that all is well. So rarely should you need to touch this particular code, at least for initial applications, but realize that's what now hands control off to you. All right, any questions? All right, so what actually, the last files we'll care about then are in these here, viewcontroller.h. Phew, not all that much here. This simply says, Kevin, do you want to take a stab at this here? What is this declaring?
Sorry.
No, I'm not picking, just feels like now we'll come full circle.
There's an instance called viewController which extends, or like its parent is UI viewController, so it
Good.
will inherit the properties that are specified there.
Perfect. So I'll tweak one word. Instead of instance, we're declaring a class called viewController that does everything you just said, that inherits all of the instance variables and methods of a parent class called UI viewController. Perfect. So by default, this template gives you this framework, but it doesn't put anything in there. We can put whatever we'd like in there. In the M file, there's similarly not all that much going on. These are mostly just stubs. And viewDidLoad is the method that's going to be called when this viewController's view comes into the screen, comes into view, and viewDidUnload is when it disappears. So what does this mean? Well, when you load up an iPhone application that has a UI on the main page, it's going to, that's the notion of the view being loaded. And this method gets called as soon as you see something on the screen. If, however, you hit a button and that screen kind of flips around like this, or it drops away, or something goes on top of it, iOS reserves the right to reclaim all of the memory that was being used by that view, at which point viewDidUnload might be called. So this is to say that views in iOS are very fragile. They are meant only to present information. They should not be used to store information. Any kind of information like high scores that are on the screen or the state of the game that you're playing on the screen should be displayed through the view, but you should absolutely still have copies of that information. The high score, whatever the state of the game board is, or whatever it is you're implementing should be stored where else besides the view? In the model, right? Or maybe some of the data is actually currently remembered in the controller, but they should not be stored only in the view. This is to say that as soon as you change screens, all the hard work you just did assembling the UI might be thrown away. So you have to be able to reconstruct it the next time viewDidLoad is called. And again, for an iOS app, think of like the stock application, the clock application, any simple application that has a button that then changes the screen to look completely different. That might mean that everything you previously saw is evicted from RAM. It's pushed off the stack altogether. All right, so there's really nothing else of interest going on in here. So let's actually go back to an interesting application that does something. So recall that we left off at the very end of class before break with this application. So let me go ahead and run it with Command R. We're going to go ahead and see a little simple ATM that looks like this. All right, so a little bit of review then. What was an IB action? Yes, Dan.
It's what happens when you click one of those buttons.
OK, good. It's what happens when you click a button, or more generally, do something with a UI widget that's on the screen. IB action is a method that could be called when, again, you do something with the interface. What's an IB outlet? Also from 2 weeks back. Yeah?
Isn't that sent the other way?
It's the other direction.
Yeah, so this goes like to, it changes. What happens here?
Good. So an IB outlet is essentially, it's generally a pointer that you declare in your .h file. And that pointer then allows you to have a virtual connection to something physical that you see on the screen. So in other words, if you want to be able to talk to the text area at the very top of the screen so you can update the account balance, or even higher up if you want to be able to update the numbers that the user has typed in, you need some way in code of talking to this drag and drop WYSIWYG interface that you created. So how you do that, you declare a pointer as an IB outlet so that you can do that dragging and dropping last time. So let's make this more concrete. In my UI nib file, and there's only one here, viewcontroller.nib. We created rather quickly this interface here last time. So let me go ahead and scroll over, and let's see what we did here. So this was a UI view. What was this? Let's see. This is a UI label. So remember that I dragged something like this. I then drag these bars outward like this and so forth. And this gave us a deposit. Whoops. This gave us this label here. All right. So quick, silly tour of what's going on the right-hand side, just so everyone's on the same page. I'm guessing you don't remember the name of the class that this label is. All right, so how do you figure this out, right? How do you go about understanding an application you've been handed or something your partner did? Well, along the top-hand side of all of these inspectors here, as they're called, there's a whole bunch of little icons. This, for instance, is the attributes inspector, which if you hover over it long enough, you should see the little tooltip that says as much. This generally touches things like the aesthetics of the thing, the colors, the font size, and the like. This one here is the identity inspector, and this will tell me exactly what class I have dragged and dropped onto the interface. So what is Interface Builder doing? What is this drag and drop interface really doing for us? Instead of you having to write dozens of lines of code, allocing a UI label, allocing 9 or 12 different UI buttons, you are telling Xcode to do all of that code generation for you by simply having dragged and dropped these various UI mechanisms wherever you want them to actually be on the screen. So in short, this drag and drop interface is by no means requisite. You can write an iPhone app without ever touching it. It just becomes a lot more tedious because you have to say alloc a UI button. Put this button at 10 pixels, comma 14 pixels so that it goes right there. And then you have to do the same thing for this button and this button and this button. So in short, it gets very tedious, at least to lay out something like this. So Interface Builder, certainly for Project 2, is a way of simplifying your life, but you'll also find that it hides certain details. And those details are often hidden behind these things called IB outlets and IB actions. So what do we mean by this? Well, let me go ahead and right-click onto the UI label and notice that a whole bunch of stuff comes up, only one of which is relevant right now. This up top there says referencing outlets, and on the left it says deposit label, and on the right it says files owner. So what does that actually mean? Well, let's scroll over to the right-hand side of the interface here and notice that anytime you use Interface Builder, this drag and drop interface, you always get mentions of files owner, first responder, and then a list of objects, everything you've already dragged and dropped into the interface. If I go ahead and right-click or click once on files owner and then look over to the right at that same identity inspector, who owns this nib file apparently? So a class called viewController. So there's the relationship. We have viewController.h, we have viewController.m, and there's this viewController.nib. What code is it that's supposed to be allowed to talk to this UI, this nib file? It's apparently viewController. So viewController.h and .m. So now on the left-hand side, what is the file's owner? It's the viewController class. So if I right-click here, there's actually a whole bunch of complexity here at the moment. And we see things like balance label, deposit label, which may sound vaguely familiar from a couple of weeks back. And then all of these digits, all of these buttons. So rather than dive back deep into this ATM that we've implemented quite quickly, let's start off with something that's much simpler. So I'm going to go ahead and close this. Stop tasks, which means just kill the simulator there. I'm going to go ahead into Xcode, create a new single view application. I'm going to go ahead and call this one nib1 for version 1. I'm going to leave everything else checked as we did before. I'm going to go ahead and save this on my desktop. And now let's go ahead and do the following. So this is the story we started telling with the template before. Let me go ahead and change the background of this like we did last time. So I've clicked on the boring gray background. I click on the attributes inspector at top right. I click on background, and we'll make it something hideous like red, and then dismiss this by clicking on the graph paper. So that now is the start of my app. Now I've got all these little widgets here, and you should see familiar UI mechanisms in the bottom right corner, like toggles and switches and the like. Let me go ahead and drag a text field up here. I'm going to go ahead and drag it to make it bigger over here. I'm going to go ahead and make it bigger over here. and then I'm going to go ahead and put a button. So I want to make a fairly simple iOS application that allows me to type in my name, then I click go, and it's going to say hello to me. And through this simple application, can we start wiring together the UI with our code and vice versa, so that then we can go back to the ATM and in turn Project 2 to start building more sophisticated tools altogether. So I'm going to add some simple little placeholder text here in the attributes inspector. So now it says name. So it's a little more clear as to what's going on. All right, so what do I actually want to do next? Well, in nib1, and let me play along in a manner consistent with code that you can play with after. In nib1, let me go ahead and declare